All right, so I guess it doesn't matter for people on Zoom, we automatically get your attendance, but those of you who are here, please either scan the QR code or go to the link and sign yourself in. Okay, and now I have a question for everyone. If you're on Zoom, please raise your hand. Does anybody not have, and when I say raise your hand, you know, put the little hand emoji up. Does anybody not have the course materials cloned to their DCC account? And if you don't know what that means, ask me. Okay, so now on Zoom, I would like you to use thumbs up if this is true. Give me a thumbs up, please, if you have the course materials cloned. Somebody's asking, what does that mean? Okay, so let's start. You know what? Back up. We're going to start by getting into our interactive session to make sure that everybody is where I'm at. Okay. So actually, I will kill this one. Start over. Okay, so the first thing we want to do is go to the DCC login page. Log in if you're not already logged in. Then go to Interactive Apps at the top. Choose CHSI RStudio Workshop. Click on that. Now you'll have this next screen, which will give you this wall time. That's how long is this gonna, is this session gonna last? And it's wall time because on computers you worry about also CPU time, but this is actual just real time, 4 hours. Threads should stay at 2 for CPUs. Memory, 2 gigabytes should be sufficient. No GPUs. And for mine, it defaults to last year's container. So I'm going to go to HIV R25 2024. So just make sure that yours says that. And you probably don't have to change anything. And then just go to the bottom and click the blue launch button. And now we wait and it will be queued. And pretty soon, hopefully, this will so cute. Okay, there we go. All right. So now, hopefully, everybody has this blue button. If you don't, it should come up soon. Click the blue button to connect, and your browser will open a new window. That will be RStudio. Okay. So I'm in RStudio. Some of you may have already opened up to the course repository. Sorry, the course materials. If not, just go over this project or even check this over here in the project in the upper right-hand side. It should give you a list of the projects that you have. And you probably don't have as many as I do, but the 2024, 2025 HIV workshop should be there. Is anyone missing that? And if I've gone too fast and you haven't caught up to me, also please say something. Well, there's a bunch more people on Zoom now. Okay. Yeah, if you attended the 0 session, we definitely did this. We did this in class. But the reason I'm going through this now is that people who didn't come to that session may not, because I don't think Josh did not get to that in his lecture. Okay. All right. Good. Well, I assume that somebody will scream if they don't have it. So I'm just going to continue now. So I'm going to open this project. Okay, and in mine, I already have the day 0 or day 1 screen up here, notebook up here. Now I'm going to go over to the lower right-hand side and click on the Files tab. And, where am I? All the way over here. Okay, so I'm going to actually click on Home to be in my home directory. And then I'll go down to where I have the course materials, which is the directory 2024-2025 HIV workshop. Okay. I didn't click it. There we go. Okay, and this has the files for the workshop. Oh, it does, but you don't have mine yet. Okay, so what we have to do first, so you should have this at least. You should at least see these files. Okay, but I've added some files to the repository since we cloned them in the first session. So what we're going to do now is something called a pull. Now, did Josh actually give a Git tutorial as well, or did he only do like reproducibility without? Did he do the planets example? Yeah, he did. Oh, he did. Okay, but does that actually involve repos? I can't remember. It does. Okay, good. All right. So what we need to do is in our RStudio, we need to go to this Git tab up here in the upper right-hand quadrant of the screen. Click on that. And then there's this, is that blue or green? Looks like it's a blue little arrow here, and it says poll, and I'm going to click on that. Hello. Okay, and mine says already up to date because I have already pushed from this place, but yours should have like some kind of googly got stuff that says compressed blah 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 blah, downloaded something. I don't know. Don't remember exactly what the message says, but it's okay. Good. So hopefully everyone is there. Richard, can you help?
Let me know.
Yeah. Okay. All right. Okay. So now we've pulled from the repository, and now we can go. Whoop, I lost my other screen here. Go back to the repository now, and I start to the file tab, and you'll click on workshop_1 data science, and then we'll go to lectures, and we're going to go to I have to fix my naming. I'll do that later. I hadn't pulled Josh's changes, so I thought it was on 02, but it's 03. Okay. Yeah, that's fine. So it's 02 day 3. Later on, after the session today, I'm going to go back and rename that file. It's going to be 03 because 03 and 04 instead of that. Okay. So you will see that change. So we want to open up the tidydata.rmd file. Anybody see that? That's what I was afraid that. Yeah, where am I? Yeah. Let me see this again. Okay, here's project. Great. Oh yeah, see what it is? That's why I said go home because it's gone all the way deep into here. Oh, and you did Google. Or at least it wasn't successful. What are you doing? No, okay. I could get here. And then you
that's GitHub.
There you go. And that's what I was talking about with the on your screen. And now it's there. Thank you. Very welcome. Oh, did I put the HTML to the repo? Okay, how's everybody on Zoom doing? Does everybody have the new files? Good. I see one thumbs up. I absolutely really appreciate responses like from Zoom, like thumbs up emojis or something, anything. This black box is kind of, yeah.
I have a question while we're reading.
Okay.
So, for like, when you pick like what kind of directory you're pulling from when you like have a wall time, what is it called? I'm sorry.
No, that's okay.
Interactive app. When you're starting right now.
You're going to interactive app, yes. Okay, and
so I have one in my lab. Like,
right.
But now it's like full queue or like run any interactive app. So that I can only use the HIV.
It's probably the partition.
Okay.
Because I run into that problem too. Like I use a different container on a different partition You know what I mean when I say partition?
Yeah.
Okay, yeah, so the DCC compute cluster has many, many machines. They are owned independently by labs and researchers. And so you pay to have access to one blade and you get priority on that machine. But it's also like set up so that people can use free cycles that other people, when other people aren't using their system, and you can get to that, but it's at a low priority. So what happens is, if you have access to two different partitions, it could be that it's trying to run it on that, I would think. Let me actually, do you want to pull it up real quick? You know what, actually, why don't we do that? Can we do that on a break? Because you're working right now. Okay, cool. I can help you fix it.
Is it called the boneyard or a different place?
The bone?
No, never mind, like the old machines where there's like, you can use them, but
Oh, I don't know about those, but that would be a good name for it.
maybe that was.
All right, guys, so sorry about all of that. We're back here again, finally, and we're gonna knit this notebook, and as long as you did the poll, it should work now. I added one thing that was supposed to be just text, and I put it in a code chunk, and that's why we had a syntax error, and I couldn't, so if you get that box, just say try again, and it should come up. Okay, so here we are. So for today, I have to wind back up. Okay, where was I? Today we're gonna talk about tidy data. What is tidy data? How to get something that's messy into a tidy format. And we're gonna do some exercises. And then I was hoping to get to dplyr. I certainly hope we still do. Yeah. So let's get right into this. So what is tidy data? Well, what is not tidy data? Well, an Excel spreadsheet that has color-coded cells, things like that. That's sort of like really a problem. But also sometimes we run into data sets where we have observations spread across rows, and we'll see examples of that. More than one piece of information in a cell, and we'll see examples of that as well. And so tidy data is defined as, I'm skipping over my pipe, I'm gonna go back to that. It means that each row is an observation, each column, oh, I'm on the wrong, I'm working at my computer. Okay, sorry. Good thing I looked up. So, what is tidy? Each row is an observation, each column is a variable, and each value has its own cell. Okay, and we're going to go through a package called Tidyr that helps us take a messy data set and put it into a tidy format. Okay, but before we do that, I need to introduce something called the pipe. So I think you know, or I mentioned before, that Tidyverse is a whole bunch of packages that were all put together, built up around the new data frame format called Tibbles. And then there's also another like kind of programming paradigm that they use, which is called a programming construct, which is called a pipe. If any of you have worked in Unix at all, pipes are used at the command line all of the time and in shell scripts. And so I think Hadley Wickham or somebody in our development said, oh, what if we use that here? And it's a really great tool. So essentially what a pipe is just like what you might think. Think about information flowing. So information flows from left to right, and you start with one thing here. So here I'm taking iris, the data set, and piping it into the head function. Head n equals 10, that means just show me the first 10 rows of the data frame. And so it's taking, this is input. So iris, when I type iris alone in R, remember what that means? It's implicitly print, right? So it's saying print iris, and then take the output of that and send it into the head function. So that's what a pipe does. So every time you see this symbol, it's taking the output of one function and putting it input into the next one, and so on and so on. And we can string these things together in a grammatical way so that you basically have a programming sentence, right? And this is another reason why I like to use the right arrow, why I use the left arrow for assignment instead of equals, because when you work with the pipe, for me, it seems very natural because there's a forward arrow also for assignment. And when you're going from left to right like this, and then you want to assign it, you can just keep going in that direction. And it's an aesthetic thing. It's not really any, there's no technical, issue there that you're solving. So here's another one I'm showing you, Iris, with the sample n function. Sample n is, I think it's a dplyr, I'm pretty sure, a dplyr function that just grabs rows at random from the, and if I get to my example that I wanted to show you, we'll see how that can come in very useful instead of just looking at the top of the data frame, because where you can see it here actually. So you see like the top of the Iris data frame, all I have is the species Setosa, and so it's not, I'm not getting a kind of a representative sample of what the rows in the data frame have. Okay, and then I can string even more commands together. So here I'm taking Iris, I'm taking 10 rows at random, sending those 10 rows into a function called poll. And what poll does is it takes this input, and this is something that in Tidyverse is kind of a very strong theme. I'm not, if I just want petalwidth out of here, I need to pass a vector to mean, right? So if I don't use this poll command, if I look at petalwidth, if I do something called select or whatever to get that column, I'm going to get a tibble back, not a vector. And mean is a very old function, and mean does not know anything about tibbles. And so the format of the input is going to be wrong. So I need to do a poll to get a vector, and then I send it to mean. So it's take Iris, take sample 10 rows, pull out the petalwidth column as a vector, and compute the mean on that. And then you see the output right down here. Now the same code without the pipe would look something like this. And I mean, maybe it's just a matter of taste. So for me, it's like you have to read from the inside out, right? And you have all these parentheses. And I've been programming for so long, parentheses are the bane of your existence. I mean, as a programmer, like everybody, it's so hard to debug. Although the interpreters have gotten a lot better at telling you, and the editors are great at like matching them up for you, but still, if you can avoid it, and this just reads much more naturally to me. And we get different answers, and of course it's because we're using a sample function and we have a set of seed, so we're getting different columns, different rows every time. Okay, and now I just have a quick exercise for you to use the MT cars data set and get the average miles per gallon from that set. From that data set. So you're not going to use the sample because I went over the whole thing. And so basically you want to come back in here and go to the console.
I have one more, right?
Oh, Richard. I see, okay. Yeah, so if you just type MT cars, it's built in, so it's there, you'll see it. If it wants to come up. Wow, is everybody so slow? That's terrible. Yeah, I think mine was hanging. Is it coming back? Are you getting a 503 or anything like that? Any errors? If you hit enter in the console, does it say anything? How about on Zoom? Anybody having connection errors or anything with their containers? Okay, nobody's complaining. I don't see the chat right now, though.
At the top of the laptop screen.
Oh, but it's probably better if I look at this screen, because then I can.
Oh, okay.
Yeah,
okay.
I can have it up. Okay, people are having issues.
Okay, so
Okay. Parisi, who had the divergent branches, when you get your container, when your container comes back, you need to, yeah. So maybe Richard, what are you doing now? You're gonna.
I was going to try to talk. What was that?
Oh, because there's one participant needs to, she's getting divergent branches, which means she probably just has to stash or something.
Okay.
Yeah. But I have your laptop. what is this day? It's like,
Yeah. Yeah.
all right, well, you could probably use my,
Yeah, yours, or I could try to run out.
okay. All right, Percy, we'll try and get you help very soon.
Okay.
I'm
I'm gonna go do that.
gonna try and get Matt because this is crazy. All right, well, the DCC thing is not Matt. That is the do compute cluster. So there's okay, thank you. There's nothing I can do about that actually, because that is. I mean, mine seems to be working. It's just very slow. Yeah.
Mine is, like, I'm not seeing it in, okay, my console is dying, so.
Yeah, mine, see that? I hit enter and it's just hanging.
Oh, okay.
Yeah.
Well, we're supposed to calculate something, right?
We were gonna calculate, we were gonna take the empty card data set, MP cards, and we were going to, which is the one that I have up there. And we're gonna calculate the average miles per gallon.
Okay.
In there.
So it's more like, replacing the iris with the empty card?
Yeah,
Okay.
but you're gonna not just replace it, right, because I'm sampling, right, and yeah. So just, yeah. And you wanna take the right column, right, miles per gallon.
Okay.
Which is called MPG in here. Yeah, this is completely hung. What is it with today? Yeah, so at least, okay, somebody said now they can connect. I don't know why this is so slow. They must have, something must have happened at the DCC.
It's a Monday.
Yeah, okay, mine's back now too. All right, so whatever happened is being recovered. And that's one thing I know, because like it'd be really weird for the whole thing to go down. They have a lot of redundancy built in, because yeah. Okay, so if you can now, please calculate the average miles per gallon in the empty cards from the empty cards data set, and do that using the pipe. Oh, I don't have. Sorry. First, in order to do this, we have to load the Tidyr. And if I had you executing the chunks like I normally do, we would have done that. So, oh, good, Brucey. I'm glad you figured it out. Okay, so so I forgot to tell you that you need to load this library if you haven't already. So just load the Tidyr using library Tidyr, and then once you do that, the code looks like this. We just take empty cars, we pull the mile per gallon to get it back there, and then send it off to mean. Oh, really? Okay, so it's not fixed. All right, yeah, it's gonna be a long afternoon. Sorry. Okay, so I was gonna go back over to my HTML, but I don't see it. So let's go back and we'll now work in the code. So in the notebook, and we're gonna go past. I talked about tidy data. This was all the pipe stuff that I just did, and the exercise is here. So and I just talked about, I talked about what is tidy, we talked about that. And now I want to get to the examples. So this is gonna be on line 58, 59 of your notebook. And we're gonna look at these tables, table 2, table 3, table 4A, and table 4B. These are, again, just like MP cards and iris, they're built-in data sets. Hadley Wickham uses them in his R for Data Science book to teach Tidyr. And so since these were very well laid out, I decided to use them as well. So in the I should have told you to execute. Okay, you know what? Slow down. I'm really losing it because like so many things going on. Okay, when you get to this code here in this table, first go over here to the run button and click run all chunks above. That will make sure you run all of the stuff in the notebook that I have, and so that R knows about it, just in case, like for example, if I've loaded libraries or things like that, make sure that you have everything that you need. And then we'll come over to this chunk here at line 58 and press the green button to run it. And when we do that, R puts all the tables down here. If I can put that down for a minute. Okay, so right now it is showing me, I'll start with this one. Okay, this is table 2. Table 2, and I think this is tuberculosis cases over time. These this original data set is that. So we see in table 2, it's not tidy. Can anybody tell me why it's not tidy? And remember, the 3 criteria are: 1, hi, we had all kinds of trouble. I'm not really sure what you should even do now. I think we've resolved it and we're working. So probably you shouldn't fix anything. You should just keep going.
What was wrong?
Somebody shared their screen on Zoom,
Okay.
and then we lost our share on Zoom. And so now I'm not sharing. I wasn't able to share my laptop. Then I think I was able to do on. It was crazy. Anyway, you want to push buttons, you can, but I actually think I.
Now we're using my laptop.
Yeah, we're using Richard's laptop. But it's
Send it to me.
But we've come to a configuration that works now, and I think we should just do it because I don't want to take more time from the class. Thanks. Okay, cool. All right, so remember, every row is an observation. Every column is a, what is every column again?
Variable.
Every column is a variable, and every cell has every value has its own cell. Okay. Anybody tell me what they think is wrong with this one? Yeah.
It's like duplicated for cases and quantitative.
Yes, exactly. We have one observation for 1999 that's spread over 2 rows. Okay, so that's what's wrong with that one. In this one, what's wrong with this one? Right, every value does not have its own cell. Right. Yes, said that right. This one? Oh, and this one is not, this one is fine, but, well, it's not exactly fine. You have to do some other stuff to it too. You actually have 2 observations. This is like not 2 observations spread over 2 rows, but 2 observations in the columns. And then this one also has to be fixed, but they're also, these are 2, we're going to join them. What we're going to do with them. Okay, so those are, so we basically have information spread over, we have one data set that's spread over 2 different tables. Okay, so there's but all of them have the exact same information. Tables 3A and 3B, and then table 2 and, 4A and 4B, and table 2 and table 3 all have the same information. And if you're wondering, yes, there is a table 1, and that's the correct one. We'll look at that one later. Okay. So in this chunk, I'm just creating, don't worry about the Poisson distribution or any of that stuff. This is just to generate some data for us to play with. A little toy data set. That is messy. And we're going to clean it up a little bit. And it's going to take forever. Well, does anybody have any questions while I'm waiting for the computer to catch up? Okay. All right. So everyone, I hope you executed that, because if you're following along, you're going to need to have that. Okay. So here I've got kind of a messy data set. All right. What are the problems? I'll just say it because otherwise we don't want to take too much time. Okay, so each row has 2 observations, right? So we've got visit 1 and visit 2. So we want to have that we want each observation to get its own row. And so we use a function called pivot longer. So there's pivot longer and pivot wider. So here what we have is we have wide format data. So we've got like rows, no, observations, or 2 observations in the same row. We want to make it longer so that each observation gets its own. And what you give it is the columns that you want to pivot. So visit 1 and visit 2. And the names to goes to visit. So in other words, I'm taking the column names and I'm going to put them in a column called visit. So that now I have one column that has the label, and then I'm going to have values in another column. So names go to visit and values go to measurement. And if this seems confusing, really, you just kind of need to, for me, it's always like, oh, I have to just run it, see what it does. Okay, this makes sense now. So we created a new column called visit, and we took the column labels from the old data frame and stuck them in as values in that column. And then we created a new column called measurement, and that took the values that were in visit 1 and visit 2. So this is the measurement for visit 1 here, and you can see visit 1 is 20, visit 2 is 11. So visit 1, 20, and 11. Okay. Oops. Okay. All right, so now we still have more problems. Did anybody have questions on that, on the pivot? Yeah.
I ran it, but my values are not the same as yours. Is that okay?
Oh, I'm sorry. I should have said that. I'm taking random.
Okay.
Right. I generated that column as the data set using using a Poisson distribution. So yeah, no. You should have different values because we won't have the same seeds. Okay. Best practice would be for me to set a seed in the notebook, but I did not. Okay. Often when I'm doing something using random numbers, I don't set a seed purposely because it should come out roughly the same every time. And if it doesn't, then I know there's a problem. Okay. So, and the next problem is that in the field description, we have 2 values. We have sex and age. So we're going to use a function called separate. And now I want you to notice, so I haven't actually changed the data frame at all. Like, right, because all I did was, let me just go back up to the code here. I didn't make an assignment here. So I'm just taking the data frame and I'm sending it to this, and it's printing the output here in the notebook. So I haven't actually saved it. Okay, so nothing's changed. So I'm just going to be building these up with pipes. Okay, so I take the data frame, I do my pivot, which I needed to do to fix the values, and now I'm going to use separate on the column. So I give it the column description. I tell it the separator is dash, and then into I give it a vector of 2 strings, sex and age. So it's saying take this column, use the dash as the separator, and create column sex and age. So it's going to do it, it's going to, it's going to take the first one before the dash and make that sex, and the one after the dash is going to be age. If I had another dash for another value in it, I would just add another name here to the next one, right? So, and sometimes you have to do this in multiple steps, depending on what the data looks like. But the idea is always the same. You're going to identify the separator, and you're going to tell them what to look for. Okay, now, so that's the separate command. And now I have another problem, and that is, I'm gonna run this chunk. I'm gonna show it to you. Okay. So when I did separate, it created this age column, but it did not know that this is an integer. This is numeric. It assigned it character because it doesn't know. And the default, if it doesn't know what to type something out, it's going to give a character, because character can be anything. So now I'm going to change that so that I get an integer. And let me do the. Oh, okay. Oh, I'm doing a bunch of steps here. So I'm not just doing that. I'm also noticing that visit this is kind of redundant, it's kind of dumb. The column's called visit, and then I have visit 1, visit 2, visit 1, visit 2. So I'm gonna get rid of the string visit in there. And then I'm gonna deal with this, drop this NA, because I have, apparently this person did not have a visit 1. So, so there's an NA in measurement. So the pipe goes like this. So first we pivot, then we separate, then I use the mutate command. And here, this is defining the column. So whatever I put here is going to be the name of the column. So it's not saying use column age. And you see this a lot in R. So I'm saying age equals as.integer age. So on the right-hand side here, that's the age in the data frame. On the left-hand side, I could call this Mickey Mouse. I'm just calling it, that's the label it's going to take. And I shouldn't do that. I should keep the meaningful name of age. But just to point out that this is not, that this age here is different from this one. Okay, and I'm taking the column visit, and I'm going to string remove from visit the string visit. And so again, this is the actual column in the data frame. This is what I'm naming it. Okay, and now I'm going to take it again and say, okay, actually, I want that to be an integer because it's also an integer now. And then I got rid of that string. And then the last thing, drop NA measurement. And now I'm going to save it, and I've got my whole tidy data frame, and I'm going to save it to DF1. So do this, and then we can see. So now we have the columns all have the types we want. Every row is an observation. Every column has one value, and every value has its own self. There we are. Okay. Now I'm going to create another data frame with the names. So we had patient IDs in the other file. So I'm going to create a names table. I think names is actually a function that I'm overriding here. That's all right. Okay. So I created this guy names. And you can see what names looks like by clicking on the first box here. Go down a little bit. So this is what it looks like. There are 6 names in here, and there are here. We have these patient IDs. So they don't exactly match up, right? I don't have a one-to-one correspondence basically between the patients in here and the patient names in the names table. And I did that on purpose because we're going to look at different ways of combining these data. So they're different. The operation is called join when you take two data sets and you want to merge them somehow. And we're going to merge these on patient ID. So the first one I'm doing is something called an inner join. So inner join the data frame and names. So it's important the order I put these guys in. Okay, because in the inner join it's not important actually. This is the one where it's really not important. Inner and outer doesn't matter. But inner join is going to take only the rows that match from both of them. So if I don't have a patient ID in DF that's in my names, it's going to drop it, and vice versa. If I have a name in here that's not referenced in DF, it's gone. So let's look at what that one looks like here. And I just get 4 rows because only 1, 3, 4, and 5 are the ones that have complete matches. Okay. Sorry, wait a minute. Why do I still have an NA in there? Oh, because I'm doing DF and not DF1. Oh, that was dumb. Oh well, I'll have to fix that. It doesn't really matter, but because it doesn't change the join at all. But I'm using the old data frame. I don't know how I didn't see that before. All right. The next join is a left join. So now it really matters. And left and right, it really matters what order this is, right? So if I say left join of DF and name, I'm going to keep everything that's in DF. And where it doesn't have a match in names, I put an NA. And so you can see that here. So I've kept everything, but this particular patient was not found in the name class. And now the left join basically does the same thing, and you should probably just have one of these, and because I think left join and right join basically is just taking them in the other order, so it's basically doing that same thing. And here we'll have all of the names, but we don't have patients here, so we don't have any of this other information. Okay. And then lastly, we have what's called a full join that keeps all of the information. Okay. Usually I do this, and then kind of like manually, like first I do that and then see what happens and look through everything and make sure, and then I decide what I want, because I'm always nervous when I say, oh, just throw away half of the data. Okay. So those are the different joins. So there's inner, full, left, and right. Okay, and now I have an exercise for you. And this was the error, by the way. I think it was probably last night, maybe I put this little line of text in here, but it's in a code chunk. So I got a syntax error because I didn't have it commented out. Oh, and I totally forget to have you guys make copies of this. So if you've changed anything in this file, we're gonna have merge errors next time we pull. But you know what? I don't think I'm not gonna deal with that today. I'll deal with that next time. I'll send you an email. Okay. So anyway, so here's your little exercise chunk here. Tidy up the tables 2, 3, 4A and 4B. And again, they should look like table 1. And I'm just giving you some hints, like to pivot the type column, paste and columns, separate the rate, and combine table 4A and 4B. And you can do that using whatever join you want, actually, I think. So table 4A and table 4B, so like, I forgot to point this out. They are, one of them is cases and the other is
population. So table 3A is the case numbers, and table 4A is the case numbers. Table 4B is the population numbers. So the goal is to get table 4A and 4B together so that they produce table 1. Okay, well, it is actually 2:25, so we should get started. So I have the solutions here. For the first one, table 2, you just need to do pivot wider instead of pivot longer. And the syntax again is you get names from. So type is saying, so let's just back to what table 2 looks like. So table 2 looks like this. So what we want to do is we want to make this wider and just have the have cases and population for each year in one row for each country. So we're going to take the names to cases and population. Names from the column type. And so then what that means is that it's going to take the column names from type. So it's going to create a cases and population columns, okay? And then values from is count. So we start here, so it's gonna take and make a new column called cases and population, and then this is gonna be in one row. Cases, so it's gonna say cases and put the count, and population and put the count. And so that looks like too much coffee, I think my hand's a little shaky. We'll do this. Okay, here we go. Right. And so that, I actually didn't really need to do this, I guess. So that should look like that. Okay. And then table 3. Table 3 looks like this. So here we have the problem that we need to solve the separate. So because we've got the rate in here, so we've got cases and population in one column. And so the syntax for that is just separate. You give it the column name as rate, and we want to change it into cases and population. You know, I didn't put the separator in there. So I don't know exactly. It definitely looks for dashes. And it definitely looks for slash. But I think also the default is that it will separate if there's spaces too. So probably I should put the separator in there just to be clear, because who knows, maybe maybe more data comes in and somebody has a space in the column or something like that, and that could mess it up. Okay. So when I do that command, when I do that separate, it looks like that. And so I'm back to table 1 format. Tables 4A and 4B are a little weird. So down, move. Huh. Maybe it doesn't have output. Oh, is it just not? I don't know if my computer, if my thing crashed or what. There we go, now it ran it. It's gone. I think I keep running this again and again, and that's why I'm not being patient. I'm just going to type it into the console and see if I can get it to. Well, I actually just want to look at table 4A, right? Right, so yeah, so table 4A is kind of weird. What it has is it's table 4A is the cases, and table 4B has the population numbers. So, and then it has the years spread out, the years in 2 columns. So first thing I want to do is I want to make this pivot longer, because I have 2 observations in this row. So I want 1 observation per row, so I'm going to pivot longer, and then I'm going to have to do a join. So first thing I did was try to fix table 4A, and then table 4B is exactly the same, except for the numbers in here are populations instead of cases. So I'm gonna pivot longer. The columns I want to pivot on are 1999 and 2000. I want these names, 1999 and 2000, to go into a field called year. And I want the values to go to cases because it's 4A. And then I'm storing that in T4A, so making a new one. Table 4B, again, same exact thing, except put values to call it population for that column. And so I run that, T4A. Oh, it's slow. Yeah, so my fixed table 4A looks like this. So now I have country, year, and cases. And then table 4B looks like this, country, year, population. And the last thing I want to do is do a full join on 4A and 4B. And that looks like that. And so I get table 1 back. Okay, any questions on that? Okay, cool. Okay, 2:30. We're doing okay, actually. All right, so that's it for tidy data. Now, one thing I forgot to do, and we're going to run into trouble. I forgot to tell you to make a copy of this and work on the copy. Remember, we called it _mine when we did this. Yeah, I forgot to tell you to do that. If you change that file at all, you're going to get commit errors. So what I'd like you to do is make a copy so that you can save it, so you can save your work, right? And then what's going to happen is we're going to do something called the git stash next time you come in. That will fix it. Okay. All right. So everybody definitely save your work in this file that you worked in a different name, because otherwise, when we do git stash later, it's going to go away. Did everybody on Zoom get that?
Yes, do we need to save as?
Yes. So go into the file menu, save as, and then put whatever you want in here. Just change the file name so that it's not the one that Git knows about, which is tidydata.rmd. Okay. All right. So any more questions on tidy data? Because I'm going to go to dplyr now.
Can you copy and paste the last code that you did with the tables into the chat? Is that possible?
All of this, or
Yes,
which part?
I had to step out for a second. I just wanted to see what you had written without holding everyone up.
Oh, okay, sure.
Thank you so much.
No problem. Oh, am I on chat in here? Shoot, I guess. Maybe this works. No, actually I can't.
Okay, that's totally fine. It's all good.
Because I'm not on Zoom. Okay.
Thank you.
Or am I? No, I'm not on Zoom. Sorry. Okay. Oh, maybe I am. Okay, this is just too much. All right. Okay. So I'm going to move on to dplyr now, and so it's going to be the same folder, and you're going to go down to 03 day 3 dplyr.rmd. Okay, and I'm going to close the other one. I'm going to close the other ones here. Okay, and so the first thing we're going to do before we do anything is we're going to go into the file menu and save as. And oh, that's weird. Oh, I closed the wrong file. Hold on. Don't follow me. No, I didn't close it. I just didn't get it now. Okay, here we go. Okay, going to the file menu and save as. And it should say 03 day 3 dplyr.rmd. Just add something to the end. I'm adding _mine, and I'm going to save it. Okay, and so now it should say your file name up here, and then we won't have too much, we won't have problems with merges. We're gonna have problems next time because of the other notebook that I forgot to tell you to save. Okay. Okay, so dplyr is sort of the next step in working with the data frame. First, you get it into tidy form using Tidyr, and then we can have a whole bunch of functions, some people call them verbs, for manipulating data. So selecting out columns, filtering out rows, doing summarize operations, mutating. We actually did mutate before, and that's Tidyr dplyr. Anyways, first thing you want to do is just like execute this first chunk here, the setup chunk. And then we're going to learn first the select function, and we're going to play with this Star Wars data set. So I'm just going to type this into the console. Star Wars. Oh, it's going to take forever. I'm resisting the impulse to hit enter 500 times. There we go. Okay, so this is, as the name implies, so this is the Star Wars data set. It's all the characters in Star Wars. So we've got Skywalker, C-3PO, R2-D2, Darth Vader, Leia, and so on. And we have the data for them: height, mass, hair color, skin color, eye color, birth year, sex, gender, homeworld. And in the knitted output, I put head. I think when you knit, it doesn't stop. Like when you print to the screen, to the console, and as a tibble, it gives you the first 6 rows by default. But I think when you knit, it actually will give you all of them unless you do something. So that's why there's a head there, to make sure that we don't end up with a very, very long HTML. If I'm wrong, Richard can correct me, but I think that's what happens.
Yeah,
Okay, so say I want to, so this is just sort of a, actually let's knit and go to the HTML. I think it's nicer to just look at this when I'm showing it to you, and then we'll come back to the notebook when, what are we doing here? What is that? That's not on this notebook, is it? No, that's, did I not knit? Oh, it's slow again. There we go. All right. Okay, so this is, so here, let's go to the top here. Okay, so if I use the command select, will give me just the columns that I want. So there's a bunch of ways to do that. So if I just want the name, birth year, and species, I just execute this command select. I and just give the column names that I want. I should mention this. In Tidyverse, they decided to get rid of the need for quotes for some of the commands. So here I don't have the column names in quotes, and I don't have to have them for select. And it gets a little weird because there are times when you actually do need to put quotes around the column names. I also don't have to like cast that. In old R, like when I wouldn't ever be able to write something like this and have it make sense. Because essentially, if I wanted to give a list of names of columns, I would have to have quotes around this, and I'd have to use the C command to put it into a vector of strings. So this is a very special type of selection, and where it will come up and kind of irritate you, or definitely irritates me, is that in some places, it doesn't work like that. In some places, it's not implemented or maybe couldn't be implemented. So there's, for example, if I want to do, I think it's in faceting in ggplot, if I want to like make plots over a certain categorical variable, right? If I want to do like, I don't know, well, I can't think of an example, but if I wanted to like go over different types of, like in the empty cars, if I wanted to make a plot, but one for each type of number of cylinders for each car, maybe I want to do miles per gallon and then go, but anyway, that wants quotes. So sometimes you'll get these cryptic errors, and if you're using, my point is, if you're using the column name without quotes and something, and you get some weird error, you might want to try to put quotes around the column name. Anyways, so this is, I'm just selecting, and I'm also like using the head command to take only 3. So I have a shorter file here. I can rename a column. So here I'm doing the same thing I did before, except just selecting birth year, I'm renaming that to age. So again, when you have these things with an age equals something, it's naming that column. Okay, so that's change the name there. I can use negative selection. So I can take all the columns except name, birth year, species. That is sometimes useful to do. There's also other, I don't think I have it in here, but there's also like, I think select everyone or everything, and yeah, there are other functions that you can use, helper functions. So here's an example of another helper function. It's starts with. So I can say everybody who starts with F. This comes in like where you might have like a date column, like you might have a bunch of dates. You want to take all the dates out. You might use a syntax like this. So now I've got every column whose column name starts with F. And then we can also use, I don't cover this because I hate it. This is something called a regular expression, or regex. And this is something that if you know what they are, great, and you want to use them, it's a very, very powerful way for matching strings, very specifically. But they are really, in my mind, they're just not intuitive to me at all. And I always get them wrong. And what I have to do is, whenever I have to use them, I have to learn it again. And it immediately goes out of my brain. So what this syntax is doing, though, it is looking for anywhere where any column where there are 2 vowels together. Any column name that has 2 vowels together. A-E-I-O-U. So it's this A-E-I-O-U and then 2, right? So I need to have 2 in a row. So I get height, hair color, birth year because I have the EA, and species because I have the IE. That makes sense. Why would you do something like this? I don't know, but there are reasons, there are ways sometimes. There are definitely use cases where you're like, oh, I need to use a regular expression here. And it's, and you'll hate it, but you'll do it. Okay. But that's beyond our scope, so I'm not gonna do that. Okay. So, and then we can also like sort our data frame. So I'm taking name, age, equal birth year, and the math, and then I want to arrange by age. So I can see that the youngest creature in this is, actually it's funny fun. I don't know what the scale is for age. Is it like what the unit is? Is it Earth years or I don't know. Somebody knows what? Yes. So Wicket History Warwick was 8. Luke Skywalker 19. Yeah, it's crazy. And then we can also arrange descending. So this is a great way to like find like the lowest. I mean, there are other ways to find minimum and maximum of things, but it's you know, like finding the tops or the oldest 3 or something is kind of can be useful. So Yoda, of course, is 896. He's the oldest. Then Jabba, and then Chewbacca. And what are we doing here? I think here I was just looks like I'm just showing more than 3. Same thing. Yeah, because then we can see the twins. Yeah. If we go out a little further, we can see Luke and Leia, who are of course twins. Oh, and I can also arrange by I can arrange by age, and then within age, mass. So, it's gonna give me the youngest, but then within the youngest one, so, and the only way, and that's actually why I went out to 5, now I remember, is because these two are the same age, because they're twins, but their mass is different. So here I'm gonna get Leia first and then Luke. If you notice up here, it showed me Luke and then Leia. Okay, so it's doing within age, and then within the same age, it will order by mass. Oh, I can also use this top, actually, I don't know if top N, is that deprecated now?
I usually like.
Yeah, you're right, slice max, slice min, yeah, so I should actually change this. They do that a lot, it seems to do a lot in Tidyverse. They're always changing, like, oh, we used to have gather and spread, and now it's pivot library for longer, and just like, yeah. So this is deprecated, but it's still there, it works. It gives you top N, so it's gonna give the, it's gonna go on age, and it's gonna give me the first 3, sorted by age. It's basically like, it's basically arranging and then giving, and then taking the head, right? So it's kind of a shorthand anyway. Okay, and now I've got some exercises for you. There is a built-in data set called diamonds, and I want you to do these things. Select only the X, Y, and Z, select all columns except price, find the top 5 most expensive diamonds, top 5 least expensive, and print only their carat cut color and clarity. So that's getting rid of the X, Y, and Z and stuff. And then find the 10 most expensive diamonds with the largest carat size. Okay, and so I'm going to go back now to the markdown file and we'll find the yeah. So the exercises, that's on line 71, and you've got a little code chunk in here that you can use on line 79. So diamonds is just called diamonds, by the way. Richard?
So, you know,
Just X to N equals.
well, you have to specify what variable.
Oh. Oh, I did the same thing with top N.
I think it allows for,
Do it?
I think it allows for ties.
Okay.
If you just did slice, let's say you did like age,
Yeah.
you just like slice 5, right? Maybe it wouldn't give you, I don't know what it was, if you had leave. Oh, gosh, Luke and Leia.
Leah, yeah.
You know, like, so just grab the first one.
Right.
While you slice max,
It'll,
maybe grab both of them because they're like 17, slice them in. They're both tied at 17, right?
19, yeah.
19,
Oh, okay, maybe. Oh, I see. It slices at the, I got it.
yeah.
Oh, I get it. So somebody got tired of doing top end and then trying to figure out how to lay. That makes sense. I can forgive them for changing that, I guess. All right, and what is the other one? Time to print letter. Okay. I think so. Everybody's probably done, right? Yes? Is everybody finished? Zoom people? Is anybody awake? I see some thumbs, okay. Thank you. All right, so I've answered most of these. I'm getting tired of typing, so I stopped. Anyway, so there are a million ways to do this, finding the most expensive diamonds. So we have the way that I did it in the notebook was using a range and descending on price. You can do top N, or you can also use, and this is superseded. That's the syntax, that's the classification for the function now, means that it's taken over by another function. It might go away sometime, but I don't think they actually have time to completely get rid of it. But they want you now, best practice, to use slice max. So this says, this does exactly the same thing. You give it, you say, I want the column price and I want to type the maximum, the 5 maximum ones, right? So that's the top 5. It's basically top 5. And then if you want to take the least expensive, we can use slice min. So the least expensive and clarity has just the columns clarity, cut, color, and caret. It turns out they all start with C, so I did the shortcut and used the helper function, starts with C. Is this a good idea? Probably, it's something, kind of thing you want to be careful with, because if the data set changes at some point and they add another column and it happens to start with C, and but it's got nothing to do with what you want here, then, then you might run into trouble. So I always kind of like, whenever I'm doing something that's so specific, I get a little bit nervous. But, or something that could be generalized, like that could bite you later. And then I did descending, and so to find the most expensive with the largest caret size, descending on price and descending on caret. And then what was the last one? Oh, that was it. Oh, no, I did the least one. What?
What does that mean? Find the 10 most expensive or like which one is
It's a really poorly worded question, and that's on me. What I really wanted you to do was find the sort of just what I wanted you to do was arrange by price and by caret size.
But which one will it prioritize?
The first one. So it's going to get the highest price, and then within that, it's going to sort it by caret size.
Not only if it has the same price.
Only if it has the same price. Yeah. So it's a dumb question. I just take that one out. Okay. Yeah. Okay. So that was it. That was, basically select and arrange. And the next function we have to look at is called filter. So select pulls out columns that you want. Filter pulls out rows. So I can take, say, everybody whose birth year is greater than 100, for example. Everybody whose birthday is greater than or equal to 600, and their name is equal to Dooku. So I want to, I should run these. We should actually, let me pull the HTML up again. I think it's better for this. Okay, so yeah, because then you can see the results as well. So everybody with birth year greater than 100 shows me like all of these old people. Now Doku is 102, so that's why I chose this one. So I want birth year greater than or equal to 600, or, so the bar is or, name equal Dooku, and so you see that I get only Java and Yoda because they're the only people over 600, and Java is just 600, so I need an equal. And Dooku is also is also included. And so this is just to demonstrate to you that you can combine logical statements. So you'll get the rows that have this or that, and if you use an ampersand, that's an and. I think you can also list things. Like, yes, exactly, I do show it there. Okay. So there's and then I'm piping here, I'm just showing you that, we can combine these using the pipe and just select our columns we want and such. And that's basically what you see when somebody's like analyzing a data set. I just have these chains of pipes commands. And for and, you can use an ampersand instead of the pipe symbol bar, I don't know what people call this. I call it pipe because that's the pipe symbol in Unix. But vertical bar is or, and an ampersand is and. But with filter, you can also just list the conditions. So birth year greater than 100, comma, sex equals male is interpreted as an and. Okay. And I should also point out that the comparison operator for equals, for equality, is equal, equal. So if you put equal, one single equal sign I hope it gives you a warning, at least. It used to be like you would just, if you were writing C code or something like that, and you put a single equal instead of a double equal, compiler had no problem with it. It goes through and basically the condition is always true because it's just saying, oh, you want to assign this variable? Great, we'll assign that value. Yeah, so that's the and. We also have helper functions, just like with select, we have the starts with, and there's also like a string contains in select. In filter, we have this helper called string detect. So I look at home world and pull out everybody that has the string in their home world. And it turns out that that's the only one, this one that Luke and C3PO and Darth Vader are from. And now, now I'm going to let you guys play with this. I wonder if I have any stupid things on this. Yeah, okay. So go ahead and handle those. Okay, hopefully everybody's pretty much done. I've typed the answers in here. I can upload this later to the Git repo. But for the first one, it's just, you know, cut equal ideal, filter. The second one is caret greater than 2. This one, I put the and sign in just so you can see that that syntax works as well, instead of separating by comma. And now, of course, everything is shut down. Nothing is running. But this would be the syntax using an ampersand instead of just putting a comma here, which you cut. When I do this, it's really important that I put these parentheses in here because it's really important in this case. I'm just thinking about the logic. Yeah, because I want this or to be evaluated together and then combined with the and. So I don't want to do like this and this or that, you know what I mean? So, yeah. So you have to, just like you have to be careful with arithmetic, you also have to be, with like some mathematical statements and parentheses, you have to do the same thing with logicals. And then, oh, I just did this to show you. So there's this really, really cool command called distinct. So whenever you have like a categorical variable, or even just a string, but it should be character. I think this is listed as a character, but it really is what's called a fact. Oh no, it's ordinal. There it is. It's right there. Ordinal or categorical. That just means that there are a distinct set of values, a finite set of values for this thing. And when you have that in the data set, this command is very, very useful, because when I see this, I say ideal, premium, good, very good, and fair. Well, guess what? If I want somebody, all the diamonds that are better than fair, well, everybody's better than fair except fair. So all I have to do is say, well, okay, I want to filter cut not equal to fair, and that will give me everybody that's better. And then for the last one, use string detect. So I want good or very good. Well, the string good is in both of those. So use string detect. Again, I'm a little bit, whenever I use these sort of string detect things, I really want to be, again, and it's something you need to be very careful with, because if your data comes in a new, like somebody updates the data and it comes in a new format and they add another column, you can be in trouble. Okay. But it's better than back in the days when you had to just say what column by number. That's something I really like about R, so I don't have to do that. Okay, any questions on those or anything else? Okay. All right, so I'm just going to go back to the HTML for the sort of the lecture part. So now there are a couple of other functions called mutate and transmutate. They essentially do the same thing. They take a function of 2 or more columns and then save them into another column. The difference between mutate and transmutate is transmutate returns only the new column, whereas mutate returns the entire data frame and then puts the new column, appends that to the data frame. Okay, so you're not, so mutate gives you everything back, transmutate only gives you the new thing. So back to our Star Wars data set, and going to select name, age, height, mass, and then compute the BMI, right? Controversial number, but it's something I could get out of this data set pretty easily. So BMI is mass divided by height divided by 100 squared, and then I'm going to say, okay, I'm going to mutate, and then I'm getting this column. It's going to give me the BMI here, and then I'm going to also compute another column, which will be an obese indicator, and obese equals BMI greater than 30. So that's going to be a logical, because it's a comparison operator, BMI greater than 30. So it's going to be true or false, right? And so that's what I get the columns that I selected out, all of them, and I'll get the BMI and then obesity, R2D2. What is it? Okay. So, And then I can, I'm showing you transmutate, so that's the difference. So I only get VMI and obese, and I throw away the rest of the data frame. There are times when you probably only want that, the transmuted, but I don't know. I don't think I've ever used transmutate except in lecture notes. Okay. Yes, okay. This is, do I even want to go through this? Okay, so here we're tuning. I want to select, this is like basically selecting across is selecting which columns I'm going to deal with. And so where is character? So I'm looking, saying what, I'm going to look at only the character columns, so only the CHRs. And then I'm going to apply this function. This is a custom function, string to upper of X. So this is just defining the function thing. I'm defining a function of X. That's going to be the input to the function. And what it's going to return is taking whatever X is and turning it all to uppercase. So I went across all character fields in the data set and turned everybody to uppercase. This is going to actually be very, very useful, especially if you're working with like a data set that was input and some people capitalize, some people don't, and you want to apply a logical to look for a string, turn it all to uppercase or lowercase, whatever you prefer, and then you can deal with it better. And then, selecting that again. Okay, and it's just doing another, like, this is doing transmute across, and again, we're going to do, yeah, I wanted to show you what it was to begin with. So here's the original data set, and then what this thing does is says, okay, across these columns, birth year, height, and mass. So I'm not using where to determine whether or not it's a numeric or whatever. I'm saying across these specific columns, so I can give that. I don't have to use a helper. And then the function is I take X and then I return X plus 1. So I took these 3 columns that I asked for, and then it added 1 across all the columns, each of the columns. Okay. Why would you want to ever do that? I don't know. But okay. And now I've got another exercise for you. Add a new column to the Daniels data frame called class. That is 1 if the cut is ideal or premium and the caret is larger than 2. 0 if not. So class is 1 if the cut is ideal or premium and the caret is larger than 2. I can't remember. There might have been an update that makes this not possible to do with mutate, but I'm going to see what happens. I forgot about this. Okay. You know what? I take this back. Don't do that exercise. I have to come up with a better one. Because this is, I'm just saying, because it used to work a particular way and then something changed and then it broke. And yeah, I should get rid of this. So don't do this one. Let's just move on to group by and summarize, and I will give you another one at some point to play with that. It's not the most, this is not the most important topic here anyway, so. All right, so let's go down. This is really cool. Group by and summarize, very, very powerful. So I'm back to the HTML just so I can look at the prettier output here. I'm going to, so I can use summary functions, right? So if I just take Star Wars and I can say summarize, average mass is equal to the mean of the mass, and median is the median age is the median of the birth year. And so I can get this nice little summary table. I can apply a function and use helper functions, just like I did with the mutate and transmutate. So I can use this across verb and go across columns, say where it's numeric. So this syntax says, for every column that's numeric, apply this function to it. So I'm taking all the numeric columns and getting the mean. And so that provides me the table with height, mass, birth year, and these are the averages for all those columns. Okay, yeah. So here I've used the function. I've defined this as what's called an anonymous function because it doesn't have a name. I just have this function of X and I tell it to do this. But I can also just give across a function. So across is just, it's going to apply this function to the columns that I've specified here. And this is na.rm equals true. These are arguments to mean. So if you have NAs in your data set, you have to, you either have to get rid of them to get the average, or you have to tell it to remove it. So mean will not take a default behavior on your on what to do with an NA, right? Okay. So this is just saying, okay, if I have an NA, just pull it out. And it's not an observation. Why do I get a warning? Oh, great, it's deprecated. I go directly to functions through an anonymous function instead. Okay, so it likes this one better, I think. Yep, it does. So it doesn't like the syntax anymore. It's good to know. What's that?
I wonder if it's just slash X. So like, I think if you got rid of the, oh, I see, sorry.
No, it's just saying argument of across is deprecated.
Yeah.
So since supply arguments directly to anonymous function instead, which is what I did up here.
Right. Okay, sorry.
Yeah, that's fine. Okay. Well, you can do it both ways, and deprecated means they'll get rid of it eventually, or there's deprecated, and then there's superseded, and at some point that means at some point they're going to pull it out or not, or they're definitely not supporting it anymore, right? So if they're bugging it, they're not going to fix it. But you know, it doesn't mean your code will run if you use it. So. And they do. They make changes to Tidyr all the time. Okay, so what are we doing here? Oh, I'm just showing that I can also use, I can give a list of functions. So I go across the columns that are numeric, and then I apply more than one function. So I can say do the mean and the median, and pass na.rm equals true to both of these functions. And so it will do that. So height 1, height 2, math 1, math 2. Probably I need to figure out a way that I can name these things. I'm sure there's some way that I can make this, like I can name the columns appropriately so that I know which one is median and which one is mean. It's going to do mean and then median. Well, actually, it's interesting. So can you see, why do I know which one is mean and median in the first two observations? Because one's missing. If you look at the top here, you see this is a double and this is an integer, right? And if you're taking the mean, it's got to return, even if it is an integer value, it's going to return a double because it's the mean you're dividing by something. In the median, they're just pulling out a value. So it's 180. That's pretty cool. Okay. Anyway, that's a pretty cool way to use so what I'm trying to get out of this is that, have you get out of this is that we can combine these helper functions and these across verbs and do multiple things on multiple columns. Okay. And then there's the group by summarize kind of idiom here. So I'm taking the Star Wars data set, I'm grouping by homeworld, and then I'm saying summarize, give me the average mass within the homeworld. Okay. And then I'm just printing out the first three here. So it's not in any particular, it's probably in alphabetical order by homeworld actually, because that's what the data set is. But here is it? Well, anyway, homeworlds are, it's printing that, and it looks like it's getting in alphabetical order. But anyway, so this is like summarizing within a particular group. And this is something that I use all the time. Oh, okay. I must have written this, it had more NAs in homeworld, but I don't see them now. So something changed in there. So I pulled out an NA. It was just getting rid of something that's not there anymore. Didn't know that. All right. Okay, so group the diamonds by cut and find the mean in each category. So what's each category? I think that's just going to be the numerics. Yeah, what I mean by each category, I think is each numeric. Find the X, Y, and Z numerics as well, means as well, and then count the number of diamonds of each color.